and here's the programming problem. So here I'm not going to show you equilibrium again. Equilibrium is the same as we had before, except that these three constraints now define consumption possibility set. What's the difference? This is the same. This is the same. This is almost the same except this one. Okay, I put the red here because this is the key of externality. Here, what I mean here is that Z actually is not just C. From the planning point of view, from the planner point of view, Z is a function of all X. What I mean is, whatever the agent choose collectively in the contracting period, everybody choose together, right? I mean, you choose, everybody choose. It turned out to be the whole big vector of X determine what C is going to be tomorrow. And the planner know that. Okay, so that's the key. The planner know that whatever C is going to show up depends on what X we choose. But for the agent, in the notion of competitive equilibrium, they don't care about this as a function of X. It's kind of in a rational expectation. I know what C is going to be. I mean, we assume that I know C, and then I decide what's best for me, right? That's what rational expectation equilibrium is. Given that, that's different make cause externality. Because now the planner can do better. The planner can manipulate this through the choice of X, okay, in general. So that's what have caused the externality. So the C of X is the source of the problem. So that's why our solution is going to be treat this as commodity. Okay, before C is just something that you see and it's not commodity because you cannot trade on it. And for us, whatever we call commodity, you can trade on it. Before you cannot trade on C, right? I mean, I never say you can trade on C. Our solution is going to be let people trade on Z, and then we kind of complete the markets. And the market is kind of complete. Questions? No?
How are you going to solve this? Because V is also maximizing something.
Good point. We couldn't. Okay. Point is, this is one thing, right? I mean, but this thing I can solve for I can have a closed form solution for this, but this is not convex anymore in general. Once we have non-convex, I mean, I don't want to deal with local optima and stuff like that. That's one thing. So this is not convex. So this is not nice as nice as what we had before. Secondly, the solution of this is not equilibrium. Even I solve this, I still don't know what equilibrium look like. Because the externality, right? Because what externality means here is that the solution to this problem is not a competitive equilibrium. Therefore, I cannot use a trick that I can solve this and I claim that is equilibrium anymore. So to get equilibrium, I have to go to solve consumer problem, guess the price, so if the price is right, and that's all. I don't do it. Okay? So that's why, to show you there's an externality, I'm going to use theoretical argument that this is externality. Okay? So that's why this we didn't do it in computer, this one. I still don't know. Maybe if you can tell me how, because my problem is, okay, let me tell you the problem. So the problem to solve the equilibrium of this world is, I believe, is because this linear world. It's going to be very difficult to kind of, I think, to get the price to adjust so that it's the market clear everywhere, right? Usually we can do it because we solve the planning problem, which is kind of, okay, that is easy. But to solve individual problem and everywhere and then try to get the price, I think it's going to be much more difficult than the usual one. Maybe I'm wrong. I mean, that's one I'm not sure. But we didn't do it, this one. Okay? But then we show that this is kind of similar to what Acemoglu and Simsek has. We assume that, let's assume that if the preferences are partially separable, by which means this one. Okay? That means marginal rate of substitution of good 1 versus good 2 is the same regardless of action. So that's what it means. So it means even if you take high action or low action, your marginal rate of substitution is the same. So your indifferent curve look kind of similar regardless of the action. The level may be not the same, okay? May not be the same. It doesn't have to be the same because only the ratios that matter. Is that okay? It's kind of, it's not that restrictive, but it's still restrictive. I showed you an example that it's not. It's quite, but then we show that, which is the same as Acemoglu and Simsek, that if the utility take this form, Prescott-Townsend equilibrium is fine. Why is that? Well, in the graph, it's like Prescott-Townsend will give you exactly this one already. Okay? The idea is because given this, once the action doesn't change the marginal rate of substitution, it won't change the incentive constraint. Okay? That means the incentive constraint with retrading is going to be the same as incentive constraint without retrading. Because without retrading, you're going to give them the same marginal rate of substitution anyway. There's no incentive to retrade after that. Okay? That's the idea. Is that okay? So because they already tangent, the tangent slope already give you the spot price if they want to trade. But they don't want to trade because they're already there. Okay? So and that's why kind of Prescott-Townsend is still okay if the preference look like that. Okay? Of course, this is sufficient condition. It's not necessary. I just want to make it clear. It's very difficult to get necessary condition for this. I haven't seen it though. I mean, everybody just talk about sufficient as most. Okay. Now, if you have no question, I'm going to move on to the solution. So the solution is going to be, as I just said, I'm going to treat Z as commodity. So that means I'm going to let agent to be able to contract on this Z. I'm going to call it price island. Okay, there's a reason for that. But let me tell you first that here, what the agent will do. The agent will it's kind of option in this sense that agent is going to go to the exchange and say, I want to buy the right to trade in this island. Okay? But the difference is, once you buy one island, you have to buy one only. Of course, you can randomly. You can say, oh, I want to buy lottery that say there's a 50% chance I will be in one island and another 50% chance I will be in another one. But once the lottery is drawn, you're there. You're not going to move. Okay? And this is a key assumption that an agent in island Z can retrade. Once you're there, you cannot move, but you can retrade within the island though. It's a bit different. Okay? Once you're there, suppose this is the island, I'm there, everybody here together, we can retrade whatever we want. But if TV is in the other island, no, I cannot go to TV and trade. Vice versa, you cannot do it either. Okay? You cannot come to one of our guys and say, let's trade.
Why do you need several price islands?
There's some non-convexity there, which, I mean, somehow the optimal pick that multiple island. And let me show you an example, maybe we can discuss on that. But, okay, again, for technical reason, the commodity space now is A, C, Q, and Z. That's why we call it extended commodity space. This is kind of a basic idea of Prescott-Townsend. Okay, the idea that they extend the arrow de Broglie to private information is to extend the commodity space instead of just good to contracts instead. Okay, here we do a small step further and say the contract itself has to be extended to include this Z. Okay, and now X is going to be X of A, C, and Q and C. I don't have to tell you what it means because it's the same, except that now you kind of also choose which island you want to be. But importantly, everybody can choose whatever they want to be in. Okay, X and it. You want this Z, you can choose, given the price.
Is the price in the price island determined ex ante or after everybody joins the island?
The exchange is going to specify to you the price in that island would be 5. Okay, but again, we're going to have in principle, there's going to be a consistency constraint that makes sure that happens. The exchange has to make sure that they put enough people there so that the price is exactly 5. Okay.